All right, 9.6, we're doing what we call identifying conic sections. So everything that we've looked at so far, the parabolas, the circles, ellipses, hyperbolas, those all fall into the category of conic sections. And we call them that because they are cross sections that are formed with cones. So actually there's a really good little photo that I can put under here. So we've got these double cones, one inverted and one kind of right side up, that if you slice, so if you slice this way, it makes a parabola. So you can see that sort of parabola shape in there. And then depending on how you slice into it this way, you get either a circle or an ellipse. If you slash just straight horizontally in it, then it gives you the circle. Any sort of diagonal gives you an ellipse. And then when you slash into it kind of going up and down, you get those two little pieces of hyperbola. So that's why we call them conic sections. We've looked at all four of them already. And we have this one specific form, which we've seen. Like this is just one example right here that we just did in this last video. When they're in that form, when x's and y's are kind of mixed all over the place and you don't really know what form it is quite yet, it can be written in this following form that looks like this. ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So it's got all of these terms. It could have x squared terms, y terms, constants, all of these, tons and tons of terms. So let me walk you through the formulas that we are used to seeing. So the general form here, we can do the completing the square step that we've been doing for the last several videos, and we can turn them into the following forms. So here's standard form for a circle. There's only one. It's always in the same orientations. There's no such thing as a horizontal circle versus a vertical circle. So this one just has one. A horizontal parabola. This is what we called vertex form. Looks like this. And if we flip it over on its side, it looks like this. And then we had the two different forms of ellipses and hyperbolas. An ellipse, if it's horizontal, remember that means that the A goes under the X stuff and the B goes under the Y stuff. And then the only difference when it is a vertical ellipse is that, oops, that should be B squared, sorry, is that the A goes under the Y, because that would be the larger of the two distances. So we just flip those terms and put the A under the Y, because that would be the major axis this time. And then put B under the X, because that would be the minor axis if it's in a vertical orientation. And finally, the hyperbola. Hyperbola, if the X one comes first, and the y is the one being subtracted, that's how you know it's horizontal. With this one, it doesn't matter if A is bigger or if B is bigger, it's always going to be in this orientation. And then when we flip, if the y comes first and the x is the one that's subtracted, that's how you know that it is a vertical form, because this means you go up and down and it opens that way. All right, so those are our standard forms. We're eventually going to take this general form and get it into any one of these standard forms. So you won't really know which one it is until you're able to look at some key features. So this one, if we write this into standard form, it then says state whether it's a parabola, circle, ellipse, or hyperbola. So just some really important things for you to keep an eye out for. If the y is squared and the x is squared, the only one that it can't be is a parabola. A parabola will never have both an x squared and a y squared. This one just has an x squared, but no y squared. This one just has a y squared, but no x squared. So parabola is out. And then let's at least get it into the form of these other ones. So if it's either a circle, an ellipse, or a hyperbola, that means the x squared and y squared are at least on one side of the equation. So I'm going to add this 2x squared term. So now I've got 2x squared was already a positive y squared and then equals 18. Okay, so now I can eliminate another one. See how I have my x squared term and then plus my y squared term? Hyperbolas don't have addition, they have subtraction. So now I can eliminate the hyperbola. So now it's either a circle or an ellipse, and they're actually really, really similar. A circle is just one specific form of an ellipse. It just means that the vertices are the same distance away from the center. That would specifically be a circle. It's kind of like how all squares are technically rectangles, but not all rectangles are squares. It's a really, really similar scenario. So with the ellipses, you've got these numbers in the denominator, which I'm not in that form yet, but I could be. With circles, notice there is nothing out front of either one of these. So it's actually this 2 that makes it an ellipse. So because it's an ellipse, I'm going to divide everything by this 18 so that I can get it into its standard form. Okay, so reduce this down. This will be x squared over 9. This will be y squared over 18. And then this is just 1. That is what finally puts it into an ellipse form. So we're identifying that it is in fact an ellipse. So now let's graph it. Okay, so the way that we graph it, our center, see how there's nothing with the x and nothing with the y? That just means the center is 0, 0. All right, and then for my vertices, I actually go up and down because this is the larger of the two numbers. So for my vertices, I go square root of 18 units up and down. And then for my co-vertices, I go square root of 9 units, which is 3, left and rights. Okay, so let's do that. So set this up. So I am centered right at the origin. Remember, I never actually plot a point. You just kind of mark where your center is. And then square root of 18 is going to be somewhere between 4 and 5. All right, because 18 is between 16 and 25. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, so for 18, I'm going just a little bit farther than 4. Just a little bit farther than 4, up and down. And then for my co-vertices, I'm going left and right 3 units, like that. And that would be my ellipse. Okay, so let's see what we've got on the next page here. This is going to be a nice little shortcut that you can use because the one on the previous page, we eventually got there, but it was like a really kind of roundabout way. It's like, well, it can't be this, but like probably it can't be this. This will give you something very specific to look at. And so we're going to be dealing with something called the discriminant, which we did when we were doing the quadratic formula. I don't know if you guys remember the discriminant, but it's actually the exact same formula. So the discriminant is b squared minus 4ac. Same exact formula that we had when we were doing the discriminant with quadratic formula. So remember, just to get our standard form up here again, okay, so notice it really only has to do with these leading terms right here. These leading terms are the only thing that you're going to plug into your discriminant formula. This is misleading. This d is not this d right here. So let me make a little note. So this is just the discriminant formula. So we're not, this d is not this d. So we've got 4 different options for our discriminant. All right, so if this comes out negative, there are 2 different possibilities. Okay, so it could come out negative, it could come out exactly equal to 0, or it could come out to be positive. Okay, so within it being negative, there are 2 different categories. Okay, so if b equals 0 and a equals c. Okay, so this one's very specific. This is going to be a really important one to have a note card on. Okay, and then if this is true and then either one of these is not true, either b isn't 0 or a is not equal to c. All right, so kind of things need to align perfectly in order for this one to work out. So these are all of the options. If this is the case, if this is negative and this is equal to 0 and a is equal to c, then this makes it a circle. All right, if this, if you've got any other case, if b isn't equal to 0 or a isn't equal to c, then it makes it an ellipse. All right, so what I want to show you is, because we narrowed this down to either circle or ellipse, and notice the reason that we ended up determining that it was in fact an ellipse is because this is a 2, but this was a 1. All right, so this is actually A and this is C. The fact that they were not equal to each other is what made it an ellipse. All right, so that is what we're looking at right here. Okay, so since A wasn't equal to C, that made an ellipse. If they had been the same, then it would have been a circle. But remember, circles and ellipses are pretty much the same thing. Okay, so next, this one, if it comes out to be exactly equal to 0, that makes it a parabola. And that leaves our last option. If the b squared minus 4ac comes out to be positive, then that makes it a hyperbola. Okay, So quick little shortcuts. When you're kind of just glancing at these things, when you are glancing at just the original formula, if, for a parabola, this is the first thing we pointed out, if there is only an x squared or a y squared, not both. That's kind of the quickest way to find out that it's a parabola. So that's how we eliminated the parabola on the first page. Hyperbola is if you either have a negative x squared or a negative y squared. Because remember, the subtraction, that's what led us to the hyperbola. And then with the ellipses and the circles, you should have a positive x squared and a positive y squared with different coefficients. With different coefficients. And then with the circle, you should have a positive x squared and a positive y squared with the same coefficients. Okay, so that's kind of the quickest way that you can just sort of look and figure out that it is, in fact, a circle, a parabola, ellipse, or a hyperbola. All right, so these ones, without writing in standard form. So we're actually not going to get these in standard form. We just want to figure out what exactly these are, either parabola, ellipse, circle, or hyperbola. So we're going to do the discriminant. So b squared minus 4ac. So b is whatever is attached to the xy. So there isn't an xy term here, so that's just 0. Minus, and then 4, a is whatever is in front of the x squared, so that is a -1 here. C is whatever is in front of the y squared, so that is a 3. All right, so we get 0 minus, and then this turns out to be -12. All right, so it turns out to be positive. It is positive, which means this is a hyperbola. Remember though, if we're looking at our shortcuts, see how this one had a positive y squared and a negative x squared? The only one that has one of them negative is a hyperbola. This one, if we do b squared minus 4ac, b squared is the xy term, and there isn't one, minus 4, a is the x squared term, which is 2, and c is the y squared term, which is also 2. Okay, so this is 0 minus, and then I have 4 times 2 times 2, which is 16. So this is a -16. Which is obviously less than 0. So then we've got two different categories here. If b is equal to 0, which it is, okay, so we got that so far. If a is equal to c, which also it is. We've got 2 and 2, so that makes this one a circle. Okay, let's compare it to what our shortcuts say. You've got an x squared, you've got a y squared, they have the same coefficient, 2 and 2. That's what makes it a circle. All right, and our last one here, b squared minus 4ac. b squared is again 0. Quick note right here. The conic is either vertical or horizontal. When b is not 0, the conic will be neither vertical nor horizontal. So you could have this sort of like sideways looking ellipse or like a sideways parabola, or I mean like a diagonal parabola. We don't have any of these in this section. So most of the ones that you're going to be looking at don't have a b squared term. And then minus 4, a is in front of the x squared, which there isn't one. So that's 0. And then c is in front of the y squared, so that's 1. So this term's 0, this term's 0. This turns out to be equal to 0, and when it's equal to 0, that's what makes it a parabola. And once again, you can see how our shortcut compared. If you have only an x squared or a y squared term, which is exactly what's happening there, you don't have an x squared, you just have a y squared. So that shortcut would lead us to a parabola.